In section 8.2, you're going to simplify, multiply, and divide rational expressions. Now, a rational expression, you can see right in the word here, it is going to be a ratio of two polynomials. So I am going to give you a few examples here. You have 3 over x, so you can have an x in the denominator. You can have an x raised to a power in the numerator and an x in the denominator. You could also have, let's just put a squared or a cubed on this one. You could have x's raised to a power in both the numerator and the denominator. Now, rational expressions are ratios of polynomials. So we have a polynomial in the numerator, polynomial in the denominator. So you can simplify them in the same way as you simplify fractions. And what I mean by that is you can divide out common factors in the numerator and the denominator. So let's look at an example of simplifying a rational expression. Now, one thing that you have to be careful about is sometimes when you simplify a rational expression or when you solve an equation, the value that you get for x, and I'm talking about an equation now, will make the expression or the equation undefined because it will make the denominator equal to 0. So we're going to start out as we're simplifying. We're going to check values that make values for x that make the denominator undefined. Okay, so we're going to simplify, and I underline this, identify any x values for which the expression is undefined. And that is what we're talking about right over here to the left. Okay, so our first question is this expression right here. This one's a pretty basic one. It just has a number in the numerator and denominator as well as one variable. So just do what you normally would. We're going to divide out the common factors, and here I can divide out 2 in the numerator and the denominator. And going back to another section earlier in the year, when you divide bases, the same bases, you subtract the exponent. So we're just going to subtract that. That is going to give us 5, and you don't need to write this out. You can go straight to what that actually equals. I just wanted to put that up there just to remind people if they are forgetting what to do when you divide bases that are the same. And so we're going to subtract the exponent, so that's going to give us 5x to the 4th, and that's over 3. Now, we want to figure out any values that will make this denominator equal to 0. Always go to the original denominator. So do not look at, because here it would look like, oh, there's nothing that will make that undefined because there's no variable. So always go to the original denominator, which means we have to ask the question, what value will make 6x to the 4th equal to 0, which will make our expression undefined? Well, if we divide both sides by 6 and take the 4th root of x to the 4th, and both in the 4th root is 0, we're going to see that x cannot equal 0. And we're just going to squeeze that in here. X cannot equal 0. All right, the next problem is a little more involved because we have to factor the numerator and the denominator. Now, hopefully you remember factoring earlier in the year to make your work a lot easier. Remember that we have to find factors of a times c. So this is our a, and this is our c, and they have to add up to b. So that's going to mean we need factors of -2 that add up to 1. And what will work there is if I make 1 and 2 are factors, I just put this negative sign in here. So when I multiply them, I'll get -2, but when I add, I get a +1. So just remember that. Now we're going to, since this is a 1, we can jump right from here to the factored form. Now that's not the case if that had been a 2. Now we'll do the same thing with the denominator. We want factors of 1 times -3, so we want factors of -3 that add up to 2. And here we have, if we do 3 and 1 and make the 1 negative, when we multiply we'll get -3, but when we add we'll get 2. And again, there's a 1 in front of this x squared term, so we can just jump from here right to the factored form. X minus 1, x plus 3. Okay, from here what you want to do is you want to cross off any common factors, and now we can easily see them here. Do not do this. Don't say, oh, I can cross off an x here and an x squared here. Think of this addition and subtraction sign as being glue. They hold terms together. You cannot break those up. The only way that you can reduce is if you have factors. So in that whole set of parentheses, it's holding these together. So they're staying together. So what we can do here now is we have an x minus 1 that can reduce with an x minus 1. So our final answer is going to be x plus 2. Nope, and I don't think I wrote it out here. I did not. Okay, so our final answer is going to be x plus 2 over, just going to draw an arrow here, x plus 3. Now we have to check for the undefined values and always go back up to the original denominator. Well, here's the factored form, so we don't have to go all the way up to the top there, but we need to go to the factored form. We have to consider when this will be equal to 0, this factor, and this, even though it's been reduced, we have to find out when that's going to make equal to 0 and what value of x will make this equal to 0. So the values that we cannot have in our denominator for x are x cannot equal 1, because that will make this whole denominator equal to 0, which will make it undefined, or x cannot equal -3. Okay, sometimes you are going to need to factor out a -1, so the lead coefficient is positive. Always try to make your lead coefficient positive. It makes the factoring much, much easier. So the example that I gave you here is going to need to be changed just a little bit. We have a negative x squared in the numerator, but I'm going to change this to an x squared minus 2x and then a minus 8. It's just going to be a better problem to show you an example here. So change this again, oops, sorry. Change this to an x squared minus 2x and then minus 8. All right, so when we factor out a -1, what's going to happen? In the numerator, we're going to have minus 4x plus x squared. Now I just factored this here, so hopefully you remember how to factor. If not, you might want to go back and to some of the earlier videos when we went over factoring. So this is going to factor to x minus 4, x plus 2. Okay, now let's just flip-flop this around. So you always want to be in standard form. So now we're going to have -1 multiplied by x squared minus 4x, and that's going to be over our denominator, which we already factored. Now here we can factor out an x. So let's do that. You always want to factor as far as you can, because that will allow you, most likely, to reduce your rational expression. All right, so we're factoring out an x squared, or sorry, just an x, because from the x squared. So we can take out an x, and there was already a -1 there. If you want to put a 1 there, that's fine. So now we're left with x minus 4, and that's going to be over x minus 4, x plus 2. Now we can start reducing. It has to go from the numerator and the denominator. So one from the numerator, one from the denominator. Again, you cannot reduce an x here and an x here, an x squared. This is glue here, here, and here. That holds them together. So we have to break them up as factors, and then when they're factors, the entire factor can reduce. All right, now we need to check for the undefined values. And again, you need to go back up to the original, well, let's put this here. You need to go up to the original denominator, set each factor equal to 0. So x minus 4 equals 0, x plus 2 equals 0. And when we solve that, our values in the denominator cannot equal 4 or -2. So I just rewrote that with -2 first and then 4. Okay, now we're going to multiply rational expressions. In order to multiply rational expressions, you want to follow these steps. Factor out all your numerators and denominators completely. So make sure that you do that, because again, what's going to happen is you're going to be able to reduce, and it's going to make your problem much easier when you can reduce. Then divide out the common factors, the numerator and denominator. Then when you're finished with that, you multiply the numerators, then multiply the denominators. Be sure the numerator and denominator have no common factors other than 1. Okay, now for the next questions that we are doing, we are going to assume that all denominators are defined. Okay, so that means we don't have to be careful on tests or quizzes and read the directions. If it says identify any x values for which the expression is undefined, make sure you do that. Or if it says assume all denominators are defined, then you don't have to do it. Okay, I'm going to give you two different methods to solve the same problem. So again, use the one that works the best for you. I prefer the one on the left, the method 1, just because it's not quite as messy as method 2, and it's actually much easier for me to follow work as well. So what we're going to do here is we're going to multiply straight across. So that's going to give us, we're multiplying the numbers to give us 30. When you multiply bases, you add the exponents, the same bases, you add the exponents. So here we're going to get 30 x to the 8th, y to the 7th, and then in the denominator, we're going to get 18, adding the exponents, x to the 5th, y to the 12th, and now we can reduce here, so we're going to divide the numerator and the denominator by 6. We'll subtract the exponent, so when we divide by 6, we're going to get 5 over 3. Subtracting the exponents, we're going to get x cubed, and here we're going to get a negative y to the 5th. Now, keep that negative y to the 5th, and then put that, okay, now what you need to do is you need to take care of that negative exponent, which means you're going to take the reciprocal here, and when you move it from the numerator to the denominator, it becomes positive. So there's our final answer. And we don't have to assume, or we're assuming all denominators are defined, so we don't have to worry about undefined values in the denominator. The second method is a little messy, and as you can see, I tried to color code this, so maybe it makes it a little easy. What we're doing here is I am reducing. I see I have a 3 here and a 9 here, so I'm dividing them both by 3, so this becomes a 1, that becomes a 3. I'm going over to the 10 here. I see a 10 and a 2, so I can divide both of them by 2. This becomes a 5, that becomes a 1. I am looking at the x to the 5th here, and I see I have an x squared in the denominator. So what I'm going to do is I'm just going to reduce that, make it x cubed, and then in the denominator it's going to go away. And then I have an x cubed here that can reduce with an x cubed here. All right, now I'm left with y. I have a y cubed and a y to the 4th, so if I multiply those together, that's going to give me y to the 7th power, so this, I'm just going to strike it the other way here. If I have a y cubed, a y to the 4th, that gives me y to the 7th, so I can cross that off. All right, now what I have left kind of is messy here. I have x cubed here. I have a 5 here, so that's going to give me 5x cubed. And then in the denominator, what do I have left here? I have a 3 y to the 5th. So that's really pretty messy, very easy to make mistakes. This is a lot neater and cleaner, so I prefer method 1. All right, now we have another example down here, and we need to factor all the numerators and the denominators. So if I factor the denominator, I can pull out a 4, and then I have x plus 5. Factor the denominator. This one can't be factored. It's x to the 1st, so it can't be factored anymore. But this is a difference of squares, so that factors into x minus 3, x plus 3. All right, once you have them factored, all you need to do now is just start reducing or dividing out common factors. So I can cross off the x minus 3 with the x minus 3. I have an x plus 5 in the numerator. It has to be numerator denominator. It can't be both in the numerator. Okay, so now what I have left, I don't have anything in the numerator, so I'm just going to put a 1 there. And then in the denominator, I have 4 times x plus 3. And that's my final answer. Again, I don't have to check to see if anything's undefined because we're assuming they're all defined. All right, last example. Oh no, I guess we have 2 more, sorry. All right, when you divide rational expressions, we're going to change this wording just a little bit so it's a little clearer. When you divide rational expressions, you multiply the first expression by the reciprocal of the second, just like when you divide fractions. Now, for the question that we're doing here, or the example, we're going to assume that all expressions are defined. All right, so let's get started with this example. We have to switch or take the reciprocal of the second one, so that's going to turn into this. Okay, now what I'm going to do, I'm going to multiply straight across in the numerator and the denominator, which is going to give me 40x to the 4th, y to the 5th, and that's going to be over 120 x squared y squared. All right, now I am just going to reduce the numbers, and then I subtract the exponents. Oops, sorry. Subtract the exponents. Okay, so that is going to give me, when I divide here, I can divide numerator and denominator by 40, so that's 1 over 3. Subtracting the exponents, I get x squared. Subtracting the exponents here, I get y cubed, and you don't have to have that 1 there. All right, another example for dividing. Again, we need to take the reciprocal of the second ratio or rational expression, and then we factor everything out. So as I flipped this, but I actually factored this out first before I flipped them. So in the numerator, this is going to be x. So this is going to be x minus 4, x plus 4. I factored this by taking out an x squared, and I'm left with x squared minus 9. And then I factored the denominator, and I'm just going to tell you what the factored form is. Again, you should remember how to factor. So this is going to be x minus 3, x minus 4, which represents this. So let me just kind of go like this to show you where these go. All right, and then this has to go in the denominator. So we're flipping that, and as I do, I'm going to pull out an x squared here. So this comes to the denominator because you have to take the reciprocal of a second. So we're pulling out an x squared, and we're left with x squared plus 2x minus 8. This still needs to be factored again, and so does this one here. These are all x to the first, and we can't pull anything else out from there. So let's rewrite this again, and you're better off rewriting. A lot of people make mistakes just by trying to do everything at once. So here I have x squared. This factors into x minus 3, x plus 3. So let me make a little more of a distinction here between those expressions. Okay, so, and then this just stays the same. Now this doesn't factor anymore, so we're just going to leave that in the numerator. This can be factored, and I'll just tell you how that factors. So this is x squared. This can be factored in x plus 4, x minus 4, x minus 2. All right, now we have a lot of dividing out common factors that we can do. Here's an x minus 3, x minus 3, numerator and denominator. Here's a x plus 4, x plus 4, numerator and denominator. Let's see, do we have anything else? Oh, we have an x squared and an x squared. It doesn't matter if one is in the first rational expression and one is in the second. All that matters is that one's in the numerator and one's in the denominator. Okay, so let's see what we have left. We have an x plus 3 and an x minus 4. Can't do anything in the denominator there. So this is our final answer. All right, last one is solving simple rational equations. So same thing, we're going to factor anything out. So we need to factor this. So x minus 5, x plus 5 over x minus 5. And easiest way to do this, again, is just to divide out common factors. We have a common factor here, common factor here. Now we're solving equations, so that means we have to figure out if the value that we find makes this undefined. So we now have x plus 5 equals 14. We're going to subtract 5 from both sides to get x equals 9. So let's look at our original denominator, which is here. That's what we look at to find our undefined values. So we just set x minus 5 equal to 0. And that means that x cannot equal 5. Well, that's not a 5, so we're okay. And this is going to be our solution for that rational equation.